It's your friendly math tutor, Miss C here, to simplify each exponential expression using the power of a product property. Here's the big idea. Every power applied to within the expression, within the parentheses, is applied to each variable and each coefficient. Let's go ahead and see how this works. So our first example is the quantity a times b raised to the 7th power. That power of 7 is applied to a and to b. So our simplified expression would look like a to the 7th times b to the 7th. And that is our simplified expression. Our next example, this is something I saw as a math teacher all the time. Students would correctly apply c to the 5th and f to the 5th, but they sometimes would forget about the coefficient of 2. That 5 gets applied to every single part of this expression, including the coefficient. So it becomes 2 to the 5th times c to the 5th times f to the 5th. Now, most math teachers are going to want you to simplify 2 to the 5th because it's a relatively small number. It really is 2 times itself 5 times, which is 32. C to the 5th times f to the 5th. And that is our simplified expression. Our next example requires us to go back to another property we've already learned in order to deal with the fact that m is already raised to an exponent. This is the power of a power property that we've done before. And here's a hint, by the way, we've actually been doing that this entire time because we are simply like with a times b to the 7th, there's a secret 1 exponent that we've been applying this rule to. That's why we end up with a to the 7th and b to the 7th. So it's exactly what we've been doing before. It just involves different numbers. So this becomes 4 to the negative 9th. And then m to the negative 2 times negative 9, that's the power on power. Remember, we multiply the exponents, gives us a positive 18. Most instructions for math problems ask that all exponents be written positively. So I have another video on that if you need instruction, but the basic idea is that we shift the part of our expression that has the negative exponent, that is the base in the negative exponents, to the other part of the fraction. So in this case, 4 to the negative 9th is in the numerator. To make that negative 9 positive, we shift 4 and its exponents to the negative, or to the denominator, and we make the negative exponent positive. So m to the 18th stays where it's at. The denominator ends up being 4 to the positive 9. That's how we make this positive, and that's our simplified expression. You might be wondering, why did we expand out 2 to the 5th to 32 and we're leaving 4 to the 9th as 4 to the 9th? It's because 4 to the 9th is a huge number. So any really, really big number, we tend to leave written in exponential form. Any number that is relatively small, we tend to write as the number itself. All right, our last example, we have lots of practice doing the power on a power property. Remember, there's a secret 1 on this 3. That's how we end up with 3 to the 4th. Then we just continue. We multiply the exponents together per the power of a power property. We end up with a to the 20th. 10 times 4 is m to the 40th. Z to the power of 3 becomes 3 to the times 4, which is z to the 12th. If you said we need to simplify 3 to the 4th, you are correct. 3 to the 4th is 81. And then we end up with 81 times a to the 20th, m to the 4th, and z to the 12th. And that is how you apply the power of a product property. Make sure to subscribe for more math content. Till next time, remember, you've got